Okay, Algebra 2 fans, let's go ahead and finish up these notes here. And the last page, we're going to talk about piecewise functions. Before we start, let me tell you your joke of the day. Why did the tomato blush? And the answer is because it saw the salad dressing. Okay, there you go. So, piecewise functions. Well, what that means, a piecewise function is actually a function, but it's made up of different functions. It's made up of different functions. Basically, what we're saying is that it's in pieces. We're going to graph different sections. Okay, it's in pieces or sections. All right, so for example, number 11 here, graph the following piecewise function. Now, when you see f of x equals, that's the same thing as saying y equals. But what you'll notice is that there are actually three pieces to f of x. The first one is x plus 4, which is a line, but it's only for x is less than 1. F of x is equal to 2 if 1 is less than or equal to x is less than 4. And then the last piece, y equals f of x equals x minus 5 if x is greater than or equal to 4. So here's what we need to do. We're going to graph these one piece at a time. So let's start with x plus 4. Now, when you graph this, you're going to graph in sections. Okay, so the first section is basically going to go up until x equals 1. Now, to figure this out, I'm going to plug in 1 for x. So if I do 1 plus 4, I get 5. So what that tells me is when x equals 1, the y value is 5. But it's less than, not less than, or equal to. So when I go to 1 comma 5, I am going to put an open circle there. That's not part of this graph x plus 4. Okay, so that's an open circle. Well, it actually doesn't look much like an open circle. Maybe I should use a pen here. But so that's open. Pardon the size of that. Now, to graph the line, I need more points. So I could plug in a different value. If I plug in something less than 1, for example, if I take x is negative 2, okay, negative 2 plus 4 is positive 2. So negative 2 comma 2 is another point right there. Now what I'm going to do is graph that. I'm going to use a ruler. Okay, so I get my ruler, and so let me line this up here, and then I'm going to draw the line. Okay, so there's my first section right there. There's the first piece, and it keeps going to negative infinity. Now the second piece, f of x equals 2 if 1 is less than or equal to x is less than 4. Well, think of this equation as y equals 2. That's a horizontal line. So a horizontal line, and it starts at positive 1, it's a closed circle. So 1 comma 2 is here. And it goes to positive 4. So it's going to stop at 4 comma 2. But notice that it's less than, not less than, or equal to. So when I graph this circle here, I'm going to make that open. Okay, that looks a little bit better. And then what we'll do is we'll draw that. Okay, so right there. Now the last piece of this piecewise function is f of x equals x minus 5, or y equals x minus 5, if x is greater than or equal to 4. So let's first of all, let's plug 4 in for x. 4 minus 5 is negative 1. So when x is 4, y equals negative 1. So let's go 4, negative 1. There's a point. And I'm going to close that because greater than or equal to. Now I need one more point to draw my line. I could use my knowledge of slope. This is like y equals 1x minus 5. The slope is 1 over 1. So I could, from here, I could rise 1, run 1. Rise 1, run 1. Okay, and it looks like that. So let me draw this. Connect it. Right there. And one other thing you can do, if you're not sure what a line or what a curve looks like, go to the calculator. Here, let me get my calculator. If I go to the calculator here, I can go to y equals. Let's say that I forget, and let me clear this. Let's say I forget what y equals x plus 4 looks like. Well, I could go y equals x plus 4. I could go zoom 6. There's my graph. Now let's say that not only do I want what it looks like, I need to be accurate here. So let's say I need some points. I could go to the table. The table is second and graph. So second graph. And I've got a whole set of values here. I've got -2, 2, -1, 3, 0, 4. Now I'd want to make sure that my points that I choose are within that domain. So I need x values less than 1. So I could do 0, 4. I could do 1, 5. I just have to use an open circle for that. Okay, so if I'm not sure what it looks like, I can definitely use the calculator. Okay, now, the next part of this, we want to answer question part A, part B, part C. What is f of -2? Well, if I've drawn this accurately, I can go to x equals -2, because that's what they're asking. They're saying x equals -2, y equals what? When x is -2, the y value is +2. There's my answer. But the other thing I could do is I could go to the function itself, which was x plus 4 for this piece. This was x plus 4, and I could put the -2 into that and do -2 plus 4, which gives me a y value of +2. Okay, so you've got options when you do this. You can do it visually, or you can do it algebraically. What is f of 1? Well, let's go to the graph. When x equals 1, the y value is also +2. Now, it's not 5 because this part was open. This was x less than 1. So I go to the second piece here, and when x is 1, y is 2. And again, if I look at the equation of this piece, it's y equals 2 for this section. So y is always 2 between +1 and +4. And the last one here, f of 7. f of 7 is over here. X equals 7 is the domain. The range, again, in this case, all the answers are going to be +2. That's not always the case, but for this problem, that's how it works out. Algebraically, if I put a 7 in for x, I get 7 minus 5, which is equal to 2. Okay, and that's how I do it. So let's take a look at number 12 here. Graph the following piecewise function. Now this time we only have two parts. We have 2x plus 8, and we have x squared. So let's start with 2x plus 8, which is going to be a line. Now it's only, though, for x less than or equal to -2. So first of all, let's find the value for y. This is y equals when x is -2. So if I put a -2 in for x, and I'll simplify that, that's -4 plus 8, which is +4. So one of my points, when x is -2, y is +4, so I'll go -2, 4, and that's going to be a closed circle because less than or equal to -2. Now I need to pick another value less than or equal to -2. So what about, say, -5? So I can do 2 times -5 plus 8, and when I work it out, I'm going to end up with -2. So -5, -2 is another point. So I'll put that on there. Let me take my ruler here, and I'm going to graph, but I'm not going to graph the whole line. I'm only going to graph this piece until I get to -2. And I'll put an arrow on there because it's going to go on and on to the left. Now, y equals x squared. Now, you just did this, but again, if you get confused, go to y equals. X squared is going to be a quadratic, and if I zoom 6 on that, now you see that parabola shape, that curved shape right there. Now we're going to go, it's from -2 all the way on to +infinity. Okay, so I could use the table for that, or again, I could just plug in some values. If I put negative 2 in for x squared, now I'm squaring a negative, I get a positive. So that point is negative 2, 4. Now normally I would say, oh, that's an open circle. But notice that on the graph, it actually puts you at the same place as the first piece, 2x plus 8. So I don't need to put an open circle there, it's going to be included. Now for a parabola, when you're graphing one of these, you can't just use 2 points to connect like a line. We need more than that because we have to get the curve shape. So let me go to the table to get some more values. So let's see, we look at this here, we have negative 1 comma 1, 0, 0, 1, 1, 2, 4. So let me go ahead and plot some of those. Negative 1, 1, 0, 0, 1, 1, 2, 4, and then it keeps going. So it's going to look something like this. So again, this is two different functions. The domain for this overall function is all the real numbers, negative infinity to positive infinity. And the range would be negative infinity to positive infinity for that. Okay, now what is f of 3? Well, f of 3 is on y equals x squared. Now actually I ran off here. So if I put a 3 in for x squared, 3 squared equals 9. There's my answer. That's the y value. What is f of negative 3? Well, f of negative 3 was the first piece of the function, negative 3 comma 2. And if I put a negative 3 in for x, if I do 2 times negative 3 plus 8 and work that out, I get positive 2. Now what's f of negative 2? Here's my graph, positive 4. And that would be for either function. If I was going to plug it in, I would plug it in where it's less than or equal to negative 2, where we have the equal to part. But again, in this case, it's not going to make a difference. 2 times negative 2 is negative 4. Negative 4 plus 8 is positive 4. Okay? Now the last one we'll do here, number 13, write the piecewise function from the following graph. So what we have here, we've got 3 different pieces. And let's go ahead and take each piece one at a time. The first one here is a horizontal line. That's y equals negative 3. So over here we'll say f of x equals, and we'll make a big bracket, negative 3 if, now that's only from, it goes to negative infinity, starts negative infinity, ends at negative 3. If negative infinity is less than x, less than 3. Less than negative 3, excuse me, less than negative 3. Now, there's no equal to part because this is an open circle. Okay, so that's open. So there we go, there's the first piece. The second piece is also a line. And it goes from here to here. Now what we could do is we could count. How about we do a little rise over run? The slope is down 2, negative 2, over 1, 2, 3, positive to the right. So we get y equals negative 2/3 x plus b. The y-intercept is positive 2. Okay, now, the domain for this is we're going from x equals negative 3, and that's included, so I'm going to put the equal to part, negative 3 less than or equal to x, less than 2. That's an open circle, so this is just a less than right there. Okay, so f of x equals negative 2/3 x plus 2. So that's y equals negative 2/3 x plus 2. Now the last piece here, this graph, this is different. This is not a line. You can see the curve. And if you look at your parent function sheet that you just did, that's going to look like y equals square root x. So there's my zoom 6. Yeah, that looks pretty good right there. Y equals square root x. Okay, so the last part of this function, y equals f of x equals square root x. There's square root x. Now let's see, we start at x equals 0, and then it just keeps going on to positive infinity. So we're going to say if x greater than or equal to 0. Now here's the thing about this, okay, and we'll write this down here. When you look at the overall function, notice the domain. You have these open circles, but where there's an open circle at -3, notice there's also a closed circle up here. Where there's an open circle at when x equals 0, there's also a closed circle here. So this domain is actually -infinity to positive infinity. It contains all the x values that you can think of, even with the open circles, because they're also closed at the same value. Now the range here would be a little bit different. The range would be -3 for this part, so that would just be one number. And then union, because we're also going to include, for the square root function, the range is going to keep going up. So it's 0 all the way to positive infinity. It'll keep rising as we go. Now for the line here, this is only from +2 to +4. But because the square root function also includes that, we can just say from 0 to positive infinity, 0 is closed right here. 0 all the way up to positive infinity. And that is the end of the notes.